Hi, Assalamualaikum warahmatullahi wabarakatuh and a very good morning. And we are from Group 5 want to present a project about application of differentiation and integration. And there is a name of members and we have Darren Anak Jambing, Gabriel Raja, Kavis Naresh, Gilbert Giltam, Muhammad Daniel Hakim and also me, Muhammad Zulfami bin Muhammad Zain. And next, we want to talk about introduction. For introduction, differentiation is the process of finding the derivative rate of change and of a function in mathematics. The practical technique of differentiation can be carried out by purely algebraic manipulations using three basic derivatives, four rules of operation and a knowledge of how to manipulate function. For the integration, integration is the process of finding a function given its derivative is called anti-differentiation or we call integration. Integration is one of the central notions in mathematical analysis and all of mathematics. In this project, our group need to use the application in differentiation and integration to solve problem 1 and 2. The problem 1 is to analyze the data collections around Parit Raja and the problem 2 is to showing the data from experimental testing of concrete prism under flexural load. Thank you.
Hi everyone. So next we'll be looking at determine the rate of change for each 15 minutes interval. So for this part, the question says for volume versus time. So volume versus time, then the thing that you need to know is rate of change dy over dx. So y2 minus y1 over x2 minus x1. Okay, so the value x and y, so we have to substitute, we set the value x as the time, which is the 15 minutes interval. 15, 30, 45, 60, 75, 90, 105, and 120. So these times will be set as x value, and then we substitute into y value to get the rate of change. So yes, to get the rate of change, so we use the x value substitute into the y equation. So equation for the volume versus time. So we substitute into that, and then we get the y value. Okay. So same goes to this, and these are the equation when we substitute, and then we got the answers. Okay, two decimal places and three, some got three. Okay, so the next one we'll look at average speed versus time. So this part same goes to volume versus time, which is you need to substitute the x value into y equation, then you'll get the answer for 15 minutes interval, and then when you substitute into the y equation, y2 minus y1 over x2 minus x1, you'll get the rate of change. So the same goes to all the value of x, 15, k, 30, and then until 120. So you have to substitute it and then to get the rate of change. Okay, then locate all relative maximum and minimum number. So for locate this, you need to for the volume versus time. So when you have the critical number x value, then you substitute into the value of fx. So when fx, then f prime x, you substitute into it, and then you'll get the answer where there is more than 0 or lesser than 0. So when there is more lesser than 0, we will say that there is a relative maximum of x, negative value. So when it is minimum of relative minimum of x, we say it as more than 0. Okay, so here we go, the value. And then next we will look at, same goes to the average speed and versus time. The same method for volume versus time. Find the relative maximum and minimum f prime x. So we substitute the value, then we see if it's negative or positive. So if it is negative, we know that it is relative maximum, and then positive, relative minimum. Okay, so we find it, and then we find the point of the maximum and minimum number. So after you find this, and then we plot for the question 3, plot graph cumulative value versus time. So plot this graph, and then you will find the rate for each minimum interval, rate of change for each 15-minute interval. So same goes to volume versus time and average speed versus time. And so use this cumulative value versus time value, substitute x into the equation, and then you'll get the rate of change. Okay, so average rate of change of graph, rate of change divided by n. How many intervals are there? 7. So So divide, then you'll get 0.301 times 10 3. So that's it. This is the relative minimum. That's all from me. Next, we'll go for the next problem.
Hello everyone, my name is Hubert Yutam and that's it. So for my presentation, for my part, I'm going to present to you guys about problem 1. For the problem 1, the question asks us to plot the graph of volume versus time and average speed versus time from both graphs. Then find the intervals where it increasing or constant, determine the rate of change for each 15 minutes interval, then locate all relative maximum and minimum number. After that, evaluate the absolute maximum and minimum number. After the evaluation, plot the graph of cumulative volume versus time from the graph. They ask to calculate the rate of change for each 15 minutes interval and investigate the average rate of change of the graph. This data is collected from air traffic around Balik Baja. From the given data, we get very much data at site B, which is in front of BH Petrol at Taman University for its location. The data were collected when the data was collected on 27 January 2021 during 10 a.m. to 12 p.m. afternoon off-peak near the road near Kluang and Batu Pahat Road. So this is the average speed, the volume. The average speed for the traffic around that area is total 70.5. As for the volume, it is total 25.2524. Okay, for the next slide. This is the first solution for the volume versus time. So before further ado, we need to plot the graph. So this is the first graph for problem 1, which is graph volume versus time. As you guys can see, the data is increasing and some of it almost constant and then decreasing a bit. So for the next slide. As for the average speed versus time graph, we already plotted it and the data shows that it is decreasing and then increasing a bit, decreasing again, and after that it is increasing upwards. So the average speed for the data for traffic, it is around 70 km per hour. For the next slide. After that, they need us to calculate the data. After we plot the graph, we will get the equation from the graph volume versus time. So we use the equation to substitute all the data, and we get for the x1 we get 85.111. For the x2 we get negative 17.111. So as you guys can see, these are the table shows. From that table, the function is increasing in the interval while decreasing in the interval. So that's for the next slide. For the average speed versus time calculation, we get the equation also from the graph average speed versus time, and for the x1 we get 60.918. For the x2, from the equation we get negative 5.362. So this is the data given. You guys can see that. So it says that f prime x, which is equal to 9 times 10 power negative 5 x squared minus 0.005 x minus 0.00294. So we use that equation and then we substitute it for the test value that we already obtained. So after we substitute, for the first one we get positive 0.2016. For the second one we get negative 0.0934. As for the third one, for the third test value we get negative 0.0294. I'm sorry, we get positive 4.3456. From that table, the function is decreasing in the interval and while increasing in the interval. So that is all from me. Thank you.
Before I start my part, I will introduce myself. My name is Dera Anajambi. I will explain about the average rate of change. From this conclusion, we will get the final average rate of change of the graph cumulative value vs the time is 0.301 times by 10 power of 3. I will describe about the problem 2. As you can see from this slide, this is a method that needs to be solved at the problem 2. I will describe about first, we need to plot the flexural strength vs the deflection. This is the result of the plot that have been done. From this graph, we can see that the graph is increasing and the start at the one of the point is decreasing. First, we need method 1. Based on the question, the energy of the concrete can be calculated by the method of portioning the area under the graph, which is known as the trapezium rule, to be find the approximate value of the defined integer. Method. As you can see from this slide, this is the graph of a flexural strength vs the deflection for the method 1. As you area of each portion. There are 7 portion labeled with a A1, A2, A3, A4, and A5. To be calculated, each of the area by using a trapezium rule method as the manual calculation to finding area under the graph. Then the area of each portion will be summed together to get the whole area under the graph. This technique is much more accurate way to approximate an area beneath a curve. Area of There are two formulas that have been used in this method one. First is the area of rectangle and the second one is area of trapezium.
Assalamualaikum warahmatullahi wabarakatuh and selamat sejahtera. My name is Muhammad Dini Hakim bin Syaful Nizam and my metric number is AF220022. Okay, today I will talk about manual calculation for area under the graph, portion A, triangle and trapezoid. As you can see, here is the table you can follow. And for the total area under the graph, you can use what we call rumus. Total area A triangle plus total area A2, A3, A4, A5 trapezoid. Here is the calculation. You can look at the right area above me. Assalamualaikum. Okay, then I would like to talk about our second method, which allow to apply a polynomial trend line to the graph, which will immediately produce the approximate function needed to determine the region under the graph by integrating that function. When a function is created, the outcome would be as such order. You can see in this graph, this is our order. Okay, then I would like to talk about our second method. Okay, as you can see, by adding a trend line of polynomial with order 2, an equation obtained which is y equal 8e minus 07 x power of 2 0.0001 x plus 0.1998. Then the equation is integrated to get the area under the graph. Here the calculation you can see all the calculation. The what we call the bottom part we have the answer. Okay, as you can see, by adding a trend line of polynomial with order 2, an equation obtained which is y equal 8e minus 07 x power of 2 0.0001 x plus 0.1998. Then the equation, okay, here our third order. This is the graph. By adding a trend line of polynomial with order 2 and equation obtained which is uh, what is this? Y equal to 1e minus 10x power of 3 plus 3e minus 0.7x power of 2 plus 0.0003x plus 0.112. Then the equation is integrated to get the area under the graph. This is also one of our order. You can see the calculation. Also, the what we call answer is at the bottom of the line. Okay, here our third order. This is the graph. By okay, this is our fourth order. Same, we have the graph here by adding a trend line of polynomial with order 2 and equation obtained which is y minus 6e minus 13x4 plus 3e minus 09x3 minus 4e minus 06x2 plus 0.0026x minus 0.156. Then the equation is integrated to the area under the graph. Okay, here also the calculation and the answer is at the bottom of the line. Okay, this is our fourth order. Same, but okay, our fifth order by adding a trend line of polynomial with order 2 an equation obtained which is y equal negative 1e minus 15xe plus 6e minus 12x4 minus 1e minus 08x3 plus 8e minus 06x2 minus 0.0013x plus 0.1541. Then the equation is integrated to get the area under the graph. As you can see the calculation below, and the answer is at the last. But okay, our fifth order by adding a trend line of polynomial with order 2 an equation obtained which is last but not the least order 6. Here the graph, and by adding a trend line of polynomial with order 2 an equation obtained which is y minus 1e minus 18x6 plus 9e minus 15x5 minus 2e minus 11x4 plus 2e minus 8x3 minus 1e negative 0.5x2 plus 0.0035x minus 0.1189. Then the equation is integrated to get the area under the graph. As you can see the calculation below, and we have the answer at the very last part. Last but not the least, order 6. Here the graph, and by adding a trend line of polynomial with order 2 an equation obtained which is y minus 1e minus 18x6 plus 9e minus 15. Okay, our third question, compare and justify the value from both methods. By using the first method, which is proportioning area under the graph by using trapezium rule, the rule that was obtained is 0.001253 m2. Subsequently, uh, while using the second method, the calculation was used by drawing the trend line on the graph and is then able to obtain the polynomial function of said graph. The value of the order is, as mentioned, value is 0.001283 m2 m power of 2. Sorry. Uh, method between method 1 and 2, 0.001283 minus 0.001253, we got 0.000003 m power of 2. This shows that the difference differences using method 1 and method 2 is 0.0003 m power of 2, where there is a little difference of approximation and percentage error. Hence, both methods are still not an accurate approximation, and there is an error in approximation, which in this case could not be evaluated because because the defined integral answer wasn't provided. However, we can make the assumption that the second method, which is Simpson rule, has the closest value to accurate quadratic approximation. The reasoning is as the proportion of partition increase, the result in error is subsequently reduced because the error calculated is much closer to accurate. Simpson's rule gives the value more converging approximation to the value of the defined integral than using trapezoid rule. Okay, our third question, compare and just
Hi, nama saya Kavish Naraj. Entry number CF2000 Senada. So, for conclusion, in our summary, we have found the solution for the equation by using Excel. We also apply input and solve the problem for the solution using knowledge from calculus book from chapter 2 and chapter 5. We have gained new knowledge and experience for how to use Excel and apply when doing this project. We also learned to solve the problem by plotting graph based on the other given. According to previous method, we also able to find the education from the equations. Overall, we discussed Google Meet and able to solve the problem 1. Problem 2. In problem 1, differentiation helped us to discover the situation of the line or intervals in graph like increasing and decreasing. It additionally helped us to discover the rate of change, relative maximum and minimum, total maximum and minimum of the intervals by utilizing first intervals. Thus, by plotting the graph of volume versus time and average speed versus time, we can find the interval and conclude whether it is increasing, decreasing, or maybe constant. From the graph, we can conclude and determine the rate of change for each interval in the problems given. Then, by plotting the graph cumulative volume versus time, we can identify the rate of change for each 15 minutes interval and the average rate of change of the graph. As for the second issue, the data given from the experimental test of foam form concrete prism density is 1600 under flexural load flexural strength kilonewtons against deflection millimeter, and the validation of the value for concrete energy using method 2 is far more accurate than method 1. This is because there is slightly difference between these two methods, which is 0.0003 meter square. From our conversation, we choose method 1, which is determined by dividing the region on the graph. Since this method uses more of the details that we measure in depth. Thus, in terms of solving the problem, which is to evaluate the worth of energy of concrete, which it is much more easy to do so. Thank you.